In April 2029, an asteroid named Apophis will pass closer to Earth's surface than many of the satellites used to transmit phone calls and weather data. Measuring roughly 340 meters across, comparable in height to the Eiffel Tower, it will be visible to the naked eye across parts of Europe, Africa, and Asia, its movement perceptible in real time as it crosses the night sky. An estimated 2 billion people will have the opportunity to observe it directly. What makes that encounter remarkable is the history behind it. 25 years earlier, scientists had calculated a genuine possibility that it wouldn't pass us at all. The discovery began quietly. On June 19, 2004, 3 astronomers, Roy Tucker, David Tholen of the University of Hawaii, and Fabrizio Bernardi, were conducting a routine survey of near-Earth objects at Kitt Peak National Observatory in the mountains near Tucson, Arizona. Using an instrument that had never previously been used to discover an asteroid, they identified a new object in an Earth-crossing orbit, catalogued under the provisional designation 2004 MN4. Based on its reflected light, the object appeared elongated, roughly peanut-shaped, and it was large. 2 days of observations were recorded. Then it moved too close to the Sun to monitor further and was effectively lost. This is not unusual in asteroid tracking. Objects are found, logged briefly, then temporarily unobservable until their orbital path brings them back into view. When Apophis was reacquired in December 2004, however, the orbital calculations derived from those 2 days of June observations produced a result the planetary science community had not seen before. On December 20th, the Minor Planet Center, the international authority responsible for cataloging near-Earth objects, issued a formal alert to astronomers worldwide, designated MPEC 2004-Y25. The figures were stark. A 2.7% probability, approximately 1 in 37, that this object would strike Earth on April 13, 2029. No object of significant size had ever carried that kind of impact probability. The scientific community mobilized immediately. Telescope time was requested across multiple continents, and researchers began gathering additional observational data as quickly as conditions allowed. Before that work could substantially alter the picture, something unexpected surfaced in an archive. Astronomers searching through stored sky survey images found what is called a precovery, a photograph of the same object taken before its official discovery date, captured incidentally by the Spacewatch survey program on March 15, 2004, and sitting unexamined in a database for months. That image contained additional positional data that could be fed directly into orbital models. On December 27, 2004, the same day Apophis reached level 4 on the Torino Impact Hazard Scale, the highest rating ever assigned to any asteroid in recorded history, that precovery data ruled out the 2029 impact. The probability for that specific encounter dropped to 0. The name the discoverers had chosen for the asteroid, Apophis, the ancient Greek form of Apep, the Egyptian serpent of chaos and disorder, the mythological adversary said to threaten the sun itself each night as it traveled through the underworld, had briefly seemed to live up to its meaning. For those 4 days, the scientific world had confronted a possibility it was not fully prepared to face. Then the numbers changed, and the acute alarm passed. With the 2029 impact ruled out, scientists could calculate more precisely what the flyby would look like. Apophis would pass approximately 31,600 kilometers from Earth's surface, closer than geostationary satellites, which orbit at roughly 35,786 kilometers and underpin modern communication and meteorological systems. Researchers estimate that an approach of this magnitude for an object this size occurs on average only once every several thousand years. That proximity introduced a complication that would extend uncertainty around Apophis for nearly 2 more decades. When modeling how Earth's gravity would interact with the asteroid during the 2029 flyby, researchers identified what orbital mechanics calls a gravitational keyhole. a region of space less than 1 kilometer wide that, if Apophis passed through it, would allow Earth's gravity to redirect the asteroid onto a collision course in 2036, 7 years after what had seemed a safe conclusion. The probability associated with that scenario was small, but it wasn't zero. And the planetary defense community had just learned in December 2004 what it meant to dismiss a small probability without sufficient data to support that dismissal. The tracking continued. For years after the 2004 alert, Apophis held a peculiar place in the scientific record. Formally ruled out as a 2029 impactor, yet carrying a small, persistent uncertainty around the 2036 keyhole scenario that couldn't be dismissed. Improved optical tracking had lowered it to level 0 on the Torino scale by 2006, but a very small probability for 2036 remained in the models. It took until January 2013 for that to change. Radar observations from the Goldstone Deep Space Communications Complex in California produced orbital data precise enough to rule out the 2036 keyhole definitively. The probability fell below 1 in a million and was subsequently refined to effectively 0. A new complication then emerged from a subtler source. Apophis tumbles through space in a complex rotation, not a clean spin, but a slow wobble. This matters because of the Yarkovsky effect, the gentle, cumulative force exerted on a rotating asteroid by the uneven release of absorbed sunlight as heat. Over time, that thermal pressure shifts an object's orbit in ways that are difficult to model precisely. In January 2021, when researchers made a precise measurement of this effect for Apophis, a previously unexamined scenario came into focus. Under specific conditions, the combined influence of the 2029 flyby and the Yarkovsky effect could align the asteroid for an impact in 2068. The probability was approximately 1 in 900,000, small but not ignorable. That uncertainty was resolved in March 2021. The Goldstone Complex and the Green Bank Observatory in West Virginia conducted joint radar observations of Apophis at a distance of approximately 17 million kilometers. The data returned was the most precise ever collected on the asteroid. Every identified impact scenario, 2029, 2036, 2068, and any other within the following century, was eliminated. On March 26, 2021, Apophis was formally removed from both NASA's Century Impact Risk Table and ESA's Planetary Defense Office risk list. No known impact risk remains for at least 100 years. There is a quiet, somber note attached to that moment. Roy Tucker, one of the 3 astronomers who discovered Apophis at Kitt Peak in June 2004, died on March 5, 2021. Just weeks before the radar campaign that finally cleared the asteroid of all identified risk. He didn't live to see it. What remained after March 2021 was not a threat. It was an opportunity, and a genuinely rare one. On April 13, 2029, a Friday, Apophis will reach its closest point to Earth at approximately 2146 Coordinated Universal Time. It will pass within roughly 31,600 kilometers of the surface, moving at approximately 7.4 kilometers per second relative to Earth. During the encounter, it will travel more than 200 degrees across the sky. At its closest, it will appear to move at roughly 42 degrees per hour, about 1 full moon width per minute, fast enough for anyone watching from the right location to perceive that motion without any instrument at all. Its expected brightness of approximately magnitude 3.1 will make it visible from dark locations across parts of Europe, Africa, and Western Asia, aided by a new moon providing ideal dark sky conditions. It will be the first time in recorded history that a potentially hazardous asteroid of this size has been visible to the naked eye during a close approach. Earth's gravity will not be passive during this encounter. As Apophis moves through the region of strongest gravitational influence, tidal forces will stretch and deform it in measurable ways. Its current rotation, approximately 1 full turn every 30.5 hours, may shift significantly after the encounter, potentially settling into a period of between 10 and 15 hours. Surface material may redistribute. Patrick Meachel, Director of Research at CNRS and a key scientific figure in ESA's mission planning, has described the encounter this way. Nature itself is conducting the experiment, and all we need to do is watch as Apophis is stretched and squeezed by forces that may reveal material hidden beneath its surface. 2 spacecraft are in position to do exactly that. NASA's OSIRIS-APEX, the repurposed OSIRIS-REx spacecraft, which delivered samples from asteroid Bennu to Earth on September 24, 2023, was redirected toward Apophis following that sample return, with approximately 25% of its fuel remaining and its instruments intact. In 2025, the spacecraft completed an Earth gravity assist, passing within roughly 2,100 miles of the surface to redirect its trajectory. It's expected to arrive at Apophis in June 2029, approximately 1 month after the Earth flyby, where it will spend 18 months in close proximity operations. Among its planned maneuvers is firing its thrusters near the asteroid's surface to kick up material for subsurface analysis, the same technique used successfully at Bennu. The mission is led by Danny Della Justina of the University of Arizona. ESA's Ramses, the Rapid Apophis Mission for Space Safety, developed in partnership with JAXA, the Japan Aerospace Exploration Agency, was formally contracted on February 10, 2026, when ESA signed an agreement of approximately €81.2 million with OHB Italia, with a total mission value of approximately €150 million. Planned to launch in April 2028 and arrive at Apophis in February 2029, 2 full months before the Earth encounter, Ramses carries a critical scientific advantage. It arrives first. While OSIRIS-APEX will study the asteroid after Earth's gravity has reshaped it, Ramses will observe it before and during the encounter, establishing the baseline from which all changes will be measured. Equipped with optical imagers, laser altimetry instruments, and spectrometers, along with 2 miniaturized CubeSat spacecraft, it will image Apophis at up to 1 frame per minute throughout the encounter from a standoff distance of approximately 15 kilometers. Together, the 2 missions will produce something that has never existed before in planetary science: a complete, documented before and after portrait of an asteroid transformed by a major gravitational encounter. What began as a deeply unsettling set of calculations in December 2004 has, through 2 decades of careful tracking and measurement, resolved into one of the most scientifically significant events our species has prepared for. The alarm passed long ago. What April 2029 holds in its place is the chance to study these ancient objects up close, to observe how they're shaped by the forces around them, and to apply that knowledge to the broader challenge of understanding what else moves through our solar system and how it behaves. On the night of April 13, 2029, approximately 2 billion people will be able to look up and see it for themselves.